I am now going to present you another aspect of the Annex 62 work, and this was focused on case studies, so looking at examples of projects where ventilative cooling was used and how the systems were performing. In this particular project that I'm presenting, these are in fact 11 kindergartens that are spread out throughout the city of Lisbon. And there are different versions of this kindergarten in order to be adjusted to the urban landscape of each location. And of particular interest, we have examples of kindergartens with 2 stories and a single story. So 2 floors, 1 floor. I'll be showing you an example, and in fact measured data in one of these kindergartens with 2 floors, okay? So Lisbon has a mild climate, but it can be rather warm in the summer. The good thing about the kindergartens for that particular sort of problem, challenge, is that in August they are closed. And so that helps to beat the summer heat, okay? In the context of the annex, Paul O'Sullivan worked on a set of very simple indicators of level of influence of different aspects in the project, okay? So here in slide 2, you can see sort of the size of the circle. You can see what were the main priorities of this project, and you can also see the floor plan of the 2 floors of the kindergarten that was monitored, and that I'll show you the results in this presentation. Regarding this level of influence and of different concerns for this project, we have the main concern of this particular project was the cost. Both the initial cost, you can see here with a large circle, but also the running costs, okay? They were important, and in fact, in Portugal, at this stage, we were trying to get out of a situation where our regulation was pushing us towards mechanical ventilation and air conditioning. And in this project, there was a goal by the client of avoiding ductwork and avoiding traditional HVAC systems and mechanical ventilation, and trying to also avoid mechanical cooling if possible. And that was the challenge that was met in this. To number 4, it's in fact number 3. And here we can see some of the features of the design. I'm going to go to slide 5 because you can see a side view of the rooms, okay, of 2 rooms of the kindergarten, and you can see the 2 modes of operation of the ventilative cooling system, okay? Now, the main feature is that it has a chimney to use stack effect to exhaust the air. Here you can see the lower floor room on the right, and you can see the chimney, and in the summer mode, you open the window, so you get more ventilation effect. And you have night-cooled internal mass absorbing the heat. You can see these arrows here, okay? Now, in the winter mode on the left, you still use the chimney for exhaust, but you have inflow of air through in a grill in the lower half of the facade behind a radiator, so you preheat the air, okay? And you also have an interesting effect of the thermal mass that is not going to be night-cooled, of course, in winter, but that it allows you for a greater stabilization of the room temperatures. So going back to slide labeled 4, you can see some images of the system, okay? So this is the inflow window behind the radiator. You can open and close it with this lever, and it's quite visible how the system works. This is quite important when you're doing these ventilative cooling systems so people understand. And then you have these chimneys. This is one of the larger rooms, and you have 2 chimneys with an adjustable inflow opening at the bottom that you adjust by turning this handle here, and you move the opening, okay? And there is an interesting picture here on the right where you see the chimneys from the ground floor moving towards the top of the building. And in this particular kindergarten, you can see them outside. In some other kindergartens, they're quite interesting. These structures, they show up in the classroom above, and they are acoustically isolated so that you have no noise ingress in the rooms through the chimneys. One feature of this design that I would like to mention was that I asked the architecture team to work on some instructions that would be posted on the wall of the buildings permanently to explain in a simple way how to use the ventilative cooling system. This was not used, so there are no instructions except for a booklet that was handed in a few years back to the first user. So after a while, after 2-3 years, you lose the concept of how you use this system. And I visited one of these kindergartens, and the user, so the person in charge of the school, told me that she was very disappointed that the skylights, which were the chimneys in her interpretation, did not provide enough light. Okay, so this is a huge problem. So there was a complete misinterpretation of what this system does and how it works. And I think that's worth mentioning if we think about design. Now, time is flying. In the design of these systems, we used detailed energy plus simulation, and this is the result of the simulations. And in these, we focused both on low levels of exceedance of optimal indoor temperature of 26 degrees. So we looked at how many hours we expected for the indoor space to be above 26. And we only had a very low number of expected hours above this limit. And we also looked at CO2 levels in the rooms and whether these exceeded the regulatory limits of 1200 ppm with an exceedance possibility of up to 1800. Now, the interesting thing is, okay, design-wise, the building performed well. The expected result was good. And then we had the opportunity to do some monitoring, okay? I'm not going to go in detail here, just to say that we also measured the airflows that we obtained from the chimneys and compared them with the simulation. There is an energy building paper the table I showed you in the latter part of my previous presentation. Now, this is also of course, in the ventilative cooling design guide. And what is done there is the application of these tables, in particular, this first table about the need for fan assistance, the application of the tables to make a decision. So you fill them out with the little circles there, and then you calculate the average numerical value of the different fields of the questions, okay? There is an issue here with the thermal mass question I'll explain in a second. And then for the need for mechanical cooling, again, we have the table filled out, okay? The issue I mean is here, when you go, does the building have a high level of exposed thermal mass? So this question would need to be rephrased, because whenever this is true, you need a low value. So you actually put the dot in the end. So this is something we need to correct. And we did that. We put a no, but in fact it is a yes. It has a high level, but it should then count as a low value. And that's why it's there. And so it's something we need to debug. Now, when you apply these tables to that building, you get 2.4, a value of 2.4 in slide 8 for the need for fan assistance. And in fact, so it's between no and yes, it's a maybe. And that's why it's kind of interesting, because we have the chimneys to assist the ventilative cooling system. So that's how we address this value of 2.4. And then in what regards the need for supplemental cooling, we got an average value of 2.1, which is again between the no and the maybe. And in fact, we use a nighttime cooling of the thermal mass as a supplemental cooling to the daytime ventilative cooling system. And so in general trends, that the application of the table provides interesting, useful results. Maria, whenever you need me to stop, let me know. Just to show you that we did some long-term monitoring of the spaces, okay? You see here a sequence of days in April of a classroom, and you can see that as the outdoor temperature rose, one of the days up to 29, the classroom stayed at 25. Of course, this benefiting from the fact that it's not sequential warm days, but it's an isolated warm day. I have more monitoring here where you can see some warmer days here towards June. So you have a sequence of days that go up to 32. And in those cases, you can start seeing indoor temperatures above 26, but not significantly. In general, the performance of these schools has been exemplary, with the problem of the commissioning and explaining the users how to operate the building, in particular as you get new tenants into these schools that do not know how the building should be used. And I think that's an open question, commissioning of ventilative cooling systems. We also measure thermal stratification with my former student Nuno Mateus, and we compared with a displacement ventilation model. We developed detailed model for NG+. The results were interesting, again, published in Energy in Buildings, if you're curious. And so this is an image outdoor, an external image of one of the kindergartens, and you can find more detail in our ventilative cooling design guides. So thank you very much for your attention.